Welcome back to Maths Plus. Today we're continuing the 2022 Paper 2 Math Solutions. We're on to question 5. So today's question is based on geometry and it'll have an area formula. So we have to find the angle first of all in this equilateral triangle. Then we have to find the area and then the perpendicular height. So that's part A. So let's get started. So we need to write down the size of the angle PQR. We know that the triangle is equilateral, so this means that all three angles are equal. So we can say that 180 divided by 3 is equal to 60 degrees. Therefore PQR is equal to 60 degrees. And we can reuse that in the next part. On to part 2. Show that the area of the triangle PQR is 16 root 3. So as you can see, that's in third form, so we will keep that in mind. Alright, so for the area we need to use this formula in your log tables. You can see it on page 16. So the area formula has the angle in the center and two corresponding sides on either side. Right, so now we have to sub in our values, so we can see that every side is the measurement of 8 centimeters and the angle in between is going to be 60 degrees. So we could use this for any angle. So let's work it out. So the area is equal to half 8 by 8 by sine of 60 degrees. So use your calculator. So that will be 32 multiplied by sine of 60 degrees, which is going to be root 3 over 2. And if we divide in by 2 on both sides here, we will get 16 root 3. And that will be in centimeters squared as we're dealing with area. So that's part 2. In part 3, hints or otherwise, so we could use the information from the last part to find the perpendicular height. Okay, so well, let's reuse that information. So we can look at the area formula and we can see that the area is equal to half the base by the perpendicular height. Alright, so let's put it all together. So we have the area, and that's 16 by root 3. Half of the base would be half by 8. And then we multiply again by the perpendicular height. Perpendicular height, just like that. Okay, shorthand. So that will give a 4 over here. Okay, and we can call the perpendicular height h. 4h, 16 root 3 is equal to 4h. Divide both sides by 4 and we will get h is equal to 4 by root 3. And that's in centimeters, which corresponds to the format up here. Alright, so far so good. And on to part B now. And we have a triangle which has a right angle in the corner. And we have two sides. We have the hypotenuse and we have the base, which could also be seen as the adjacent. So we need to use the Pythagoras theorem to find the distance hk. So let's put all that together. So we're going to use this one here. So we're going to go h is 30. And the O and the A will be, A is 12 and O is hk. So h squared hypotenuse squared is equal to O squared opposite squared plus the adjacent squared. And we will get 30 squared is equal to hk squared plus A squared, which is 12 squared. So h squared So we just look at that back to front, bring over the 12 all the ways over here and subtract it. So we get 900 for 30 squared and 144 for 12 squared, and therefore HK is equal to the square root of that difference, 900 minus 144, and HK is equal to 27.49 or 27.5 to 1 decimal place, and that's in centimeters. And that's it. So a big thanks for watching Maths Plus. Don't forget to watch the channel for my next exciting video.